Yeah, hey everyone. So for today's topic, I wanted to talk about Java stack memory. So we've talked about heap, we've talked about RAM, but another aspect of memory and memory management within Java is stack memory. So I wanted to talk about what it was, why it's so important, and the infamous stack overflow error that we see pretty commonly within Boomi and just general integrations. So with that said, what is stack memory? So we've talked about memory in Java, and as you guys know, any sort of Java application needs RAM to run. So if we're using our JVM for our use case, it needs RAM. So the JVM, for essentially to ensure memory is only used when needed, its best case scenario, memory management, the JVM is going to divide this memory between heap and stack memory. So we've talked about heap memory. We've talked about the garbage collector, how heap is essentially stores objects, loads JRE and JDK classes, items of that sort. So what stack memory does and what's different with this is it's temporary memory, and it's going to store variables when a specific method is called or references to objects in heap. So those are kind of the two major use cases and two major reasons stack memory is used. So stack memory is specific to a particular thread of an execution. So we've talked about threads being this unique path, this small processing unit. So essentially think of it this way: if it's only accessible to a particular thread, it can't be accessed by other threads, and threads are short-lived as well as these methods that are being invoked. So once that specific method is complete, that stack memory is going to be cleared. So it's last in, first out logic, meaning that let's say I have A, B, C on my stack. C is going to be the first one out as it was the last one in. So think of it this way. Let's say you have some sort of variable or a reference that is declared. That method is called. You have a reference or just the variable is stored in stack memory. And then once that method is complete, whatever that thread is doing is complete. That's it. It's removed. Pretty simple. But with that said, just think about some of the problems we can see with that. So with heap, we normally see an out of memory condition. So like Java out of memory, heap space, something along those lines. So when you run out of stack space, the Java runtime is now going to throw a stack overflow error. So that essentially means that this specific stack space is not short-lived. Usually, as I show right here, it's due to some sort of looping logic. So if you see this error, look for a loop or any sort of looping-based logic in an integration process. Chances are what is happening is that method is never getting cleared because it keeps looping on itself or on that specific connection. So all those variables, all those references are going up, and it's increasing the stack space to the point where it throws a stack overflow error. So you may think, oh, it's just memory. Let's just throw more memory at it. That's not the best way to go about this. The way you should go about this is process design. Just because a majority, so let's say you give RAM, most of the RAM is dedicated to heap. You can obviously, there's parameters to fine tune to increase stack space or increase heap space, but I wouldn't suggest going this route just because maybe it loops more in a specific integration process or use case where there's more data. And then in turn, you would just get this stack overflow anyway, and increasing memory is not a viable solution for this. So we do have a non-looping logic-based pattern that is in our community right now that essentially is able to call a specific connector or whatever it is based on a document ID. That's a good workaround should it be available. The only concern with this is you would need to know the amount of documents you want to pull based on this non-pagination, non-looping pattern, or you would need to implement some other form of logic that essentially would check to see if there's any documents left and continue processing. Or another way around this is just pull less documents. Let's say you hit a Stack Overflow at 1,000 documents. Do you hit it at 500 documents? If yes, Then what about 250? And let's say you hit a certain number that you don't hit specifically Stack Overflow. You should use this condition or this number, and you should just run it more frequently. Let's say 250 is the magic number. You have 1,000 documents. Run it 4 times throughout the night or whatever it may be, so that your source, destinate, like whatever's going on with that, has the needed data at that specific point in time. All right. Sounds good, guys. Enjoy the rest of your day.